Well, let's go the other direction. Let's multiply scores by 10. Now you can see when I added 10, it's a nice complement or an addition of 10 across the board. And of course, as we discussed before, that increased the mean by 10. But also, and again, this is a chapter 4 topic, the numbers are not more spread out. They merely go, instead of from a range of 4 to 10, or 4 through 10, someone could argue, they go from 14 to 20. And therefore, they're sort of in the same compact zone, if you will. So they're not more spread out, but indeed the mean is higher by exactly 10. Can I do that again? Sure. Transform compute variable. And this time I want to call it scores, how about by 10? And what that means is multiply by 10. And what I'll do here is adjust this. Scores, and I think it's an asterisk. Scores by 10. And again, if I were really doing this, one thing I would want to do is be sure to leave a trail with the syntax. I think that's important. What you don't want to do is lose track of what you're doing. That's the most important thing. So I'll go ahead and say, okay, I hope it likes it. Hold your breath. It did. Okay. So I got that, and then I'm going to go back to the original data screen, and sure enough, there's scores by 10. So look what I did there. 8 is now 80, 7 is 70, 9 is 90, etc. Now, what's going to happen to the mean? The old mean, if you'll remember, let's go analyze descriptives. Descriptives was 7.9, and the standard deviation is 1.45, really. Now, in this case, what are we expecting the new mean to be? Well, of course, we're going to multiply by 10, so the new mean should be 79, right, on the nose? Now, this would be kind of an interesting bit of trivia. What will happen to the standard deviation? And again, this is a topic we'll get to in Chapter 4 in earnest. The standard deviation won't be the same, and I want you to consider why. Going back to Chapter 3 here, look what happened to the range of numbers. The numbers are no longer from 4 to 10, which is pretty compact, or 14 to 20, which is pretty compact. Now look what I've done. It's from 40 to 100. Holy cow. That's a lot more of a range. My gosh, that's 60 instead of 6. So what's going to happen to my standard deviation? Well, it should be tenfold. And let's check it out. Analyze, descriptive statistics, descriptives. Let me get scores out of there and drop in scores by 10, multiplied by 10. And watch, and isn't that cool? It went from 7.9 to 79. And sure enough, 1.45 really to roughly 14.45. Isn't that cool? The standard deviation was multiplied by 10, but I hope you have a visceral feel for that. In other words, just a gut feeling. It's almost like, when I was a little kid skipping rocks, I think I had an implicit understanding of why the rocks were skipping across the lake, because it was the flat part of the rock was just bouncing essentially off the water. It made sense to me physically. And by the same token, I hope this makes sense. What I've done when I've multiplied by 10 is I've introduced big gaps between the numbers. No longer just between 8 and 7. 80 and 70 is a gap of 10. And of course, from 40 to 100 is a gap of 60. And of course, that influenced not just the mean, bumped it by 10, but also, of course, the standard deviation, which is, again, a Chapter 4 topic.